Okay, this is Geometry, Lesson 3, Part 5. We're going to take a time travel back and look at slopes of lines. Let's do the warm-up. Find the value of m. Remember from geometry, m is the letter that we use for the slope of a line. Go ahead and pause the video because I'm going to just keep going on and we'll go ahead and look at the answers. So I'll give you just a few seconds. Go ahead and pause the video now. Okay? Let's look at the solutions. 2/5, -3/2, undefined, and 0. For question number 3, remember you can never divide by 0, so when you get 0 in the denominator of a fraction, it immediately becomes what we call undefined. This means that it's not a real number. However, look at number 4. We should get 0 in the numerator. And 0 in the numerator is perfectly fine. 0 in the numerator means that the slope is 0. The only exception to this, which the warm-up is not going to go over, is when you have 0 over 0. Okay, if you ever get 0 over 0, that itself is also undefined. But it's given a special name, which we don't talk about in geometry, but I'll just mention it right now. 0 over 0 is called an indeterminate. All right, well, when you get to pre-calculus or calculus, you'll remember that. But we don't need to talk about that further. Let's press on. Here's our objectives. We need to find the slope of a line. We need to use slopes to identify parallel and perpendicular lines. So those are our goals for this lesson. The vocabulary, we need to be familiar with rise and run and what slope is. Okay, the slope of a line in a coordinate plane is a number that describes the steepness of a line. Any 2 points on a line can be used to determine the slope. Just think in your imagination of the steepest hill you've ever had to climb. That hill would have a really large slope. So its steepness in measure would be a really pretty big number. Also, if you've ever walked up a really short incline, something that's not difficult to walk up, but it's not flat either, then that would have a really short or small slope, and any flat surface would have a slope of 0. If you've ever gone rock climbing and have to climb up a vertical wall in rock climbing, that would be a slope of undefined, because that's as steep as they get. That's called an infinite slope. All right, let's look at the definition. The rise is the difference in the y values of 2 points on a line. So look at the graph on the right-hand side. We've got a y2 and a y1. So if you take y2 minus y1 from this picture, you get the number 6. 6 is called the rise. Now, I'm going to mention this right now. The rise can be negative. So unfortunately, the word rise isn't probably the best word to use, but that's what we're going to use. So sometimes a rise can be a negative number, which means you'll actually be dropping. Okay? But I thought that was worth mentioning right now. x2 minus x1 is called the run, and in this example the run is 4. And just like the rise, you can also get a negative run. I personally like to call a negative run a retreat, and a negative rise I like to call a drop. But that's me, so we'll just press on. The slope of a line is the ratio of the rise to the run. So if you have x1, y1, and if you have x2, y2, and if those are any 2 points on a line, then the slope of the line is letter m, that's the letter we choose, and that's equal to y2 minus y1 over x2 minus x1. In some math classes, you'll hear this as the change in y over the change in x. Use the slope formula to determine the slope of each line, a to b. Let's work this one together. All right, so let's look at line a to b. Well, A is located at the point -2, 7, it looks like, and B is located at 3, 7. So the y values are both 7. Well, 7 minus 7 is 0, and 0 in the numerator would give me 0. And since AB is a flat surface, it's a flat line, it's going to have a slope of 0. Substitute in the values, -2, 7 and 3, 7, and voila, we get 0. All right, let's try to find the slope of A to C. Well, we already know that A is located at negative 2 comma 7. C is located at 4 comma 2. So let's take the y value of 7 minus 2, which is 5. That's the numerator. And let's take negative 2 minus 4. That's negative 6. That's the denominator. So we should get, I believe, negative 5/6. Substitute in the values in the formula. Simplify. Negative 5/6. And I would love to be able to show this with my cursor, but I can't use the cursor here in the presentation. But if you put your finger at point A and drop down 1, 2, 3, 4, 5, that's negative 5, and then run to the right 1, 2, 3, 4, 5, 6, that's one way to use the slope, to count downwards and then to the right. So all negative slopes, by the way, have this dropping from left to right feature. They always drop from left to right whenever you have a negative slope. All right, let's find the slope of AD. Well, we don't really have to do any calculations. We're going to, but we don't have to. Notice it's a vertical line. Well, just like that rock wall that you're climbing, this is a vertical slope, so this is called undefined. Let's go ahead and find the ordered pairs. Negative 2 comma 7, negative 2 comma 1. Plug those in. Well, we get 0 in the denominator. And 0 in the denominator is not good. And I'm looking at my PowerPoint presentation. Do you see where it says 2 minus negative 2? This is unfortunate. This is a typo. That should actually be negative 2 minus negative 2, which gives you 0. So 0 is correct, but my presentation has it typed in incorrectly. So put a negative 2 in front of that 2 there, and then it's correct. The slope is undefined. Remember, a fraction with 0 in the denominator is undefined because it is impossible to divide by 0. What we mean by that is that dividing by 0 doesn't give us what's considered to be a real number. And this is what we mean by it's impossible or it's undefined. We don't get a real number when we divide by 0. Okay, let's look at example 1D. Use the slope formula to determine the slope of each line. So let's find the slope of CD. Do you think you can do this one on your own? Go ahead and pause the video, see if you can do this one on your own, and then resume. I'll give you a second to pause the video. Okay, let's see what the slope of the line is. Substitute in 4 comma 2, that's where C is located, and negative 2 comma 1, that's where D is located. Plug this into the formula. We're going to get negative 1 over negative 6, and a negative divided by a negative is a positive. So we get a positive 1/6. Again, go ahead and put your finger on point D on the screen. You can now rise up 1 and then run to the right 6 times, and that's the slope. Let's check it out for ourselves. Go ahead and use the slope formula to determine the slope of line JK through the ordered pairs 3 comma 1 and 2 comma negative 1. Go ahead and pause the video now. All right, let's see what you got. Substitute 3 comma 1 for x1, y1 and 2 negative 1 for x2, y2 into that slope formula. Well, we get negative 1 minus 1, which is negative 2. We get 2 minus 3, which is negative 1, and yet again, a negative divided by a negative is a positive. So we get a slope of 2. Let's look at some picture examples of the different kinds of slopes that we can have. Positive slopes always rise from left to right. We travel from left to right direction in a graph. And so the first graph you see rising, so this is a positive slope. Negative slopes always go downwards from left to right. So there's a drop in a negative slope. Zero slopes are always flat and horizontal. Another word for flat is horizontal. And undefined slopes are always vertical. One interpretation of slope is a rate of change. If y represents miles traveled and x represents time in hours, the slope gives the rate of change in miles per hour. Now we're going to start looking at problems that use this rate of change. And I just want to make a special note. these are word problems. So when you solve them in class for me on quizzes and tests and homework, I want to see your answer in the form of a sentence, a contextual sentence talking about what you just found. Justin is driving from home to his college dormitory. At 4 o'clock in the afternoon, he's 260 miles from home. At 7 o'clock in the afternoon or in the evening, he's 455 miles from home. Graph the line that represents Justin's distance from home at a given time. Find and interpret the slope of the line. Well, the best thing we should do right now is just use our imaginations. Let's put ourselves in the car with Justin at 4 o'clock in the afternoon. We know that the moment we're in the car with Justin, he's traveled 260 miles. So we're going to spend 3 hours with Justin in the car, and we know that 3 hours has passed or elapsed. And now he's 455 miles from home. Because we want a rate of change, we want to know basically how many miles per hour he's traveled. Did you notice the units? Miles per hour? Well, that means that this is going to be the difference in the miles divided by the difference in the times. Or, because this is a lesson about slopes, the change in y over the change in x. We're going to let the miles be the y values, and we're going to let the times be the x values. Okay, so we graph. At 4, 260 is his first location, and then 3 hours later he's at 7, 455. The x-axis is the time axis, so actually it's not x, it's t. And the y-axis is miles, so actually it's not y, it's m. Using these points, plug them in to graph the line and find the slope. We get 65 after we plug in the values. Now, this is the sentence that I'm hunting for. It's very easy to write a sentence, but you have to do it. It's really important, not just because I'm asking you to, but it's really important to be able to write out contextually, meaning you really understand what the problem's about and you're able to communicate that problem back to whoever's asking the question. That's really a skill that colleges are looking for. So we know the slope is 65, which means Justin is traveling at an average of 65 miles per hour over those 3 hours. All right, try this one on your own. Use the graph below to estimate how far Tony will have traveled by 6:30 p.m. if his average speed stays the same. Let me give you a little bit of extra information. Because we're trying to estimate something in the future, this is called a prediction or an extrapolation. We're assuming that he's traveling at the same rate and that he doesn't change his rate. So whenever that happens, I'm going to say if his average speed stays the same. So, can you find the slope of the line? First of all, go ahead and pause the video, see if you can find the slope of the line, and see if you can tell me how far he will have traveled by 6:30 in the evening. Okay, let's see what you came up with. Since Tony's traveling at an average speed of 60 miles per hour, by 6:30, Tony will have traveled 390 miles. Okay, we have two theorems we're going to talk about here. The first one, Parallel Lines Theorem. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. We don't say that they have the same measure and slope because remember, vertical lines are undefined, and undefined means there's no real number. So we can't put a measure on vertical lines, unfortunately. So what we're going to say is, if they're not vertical, then they're parallel if and only if they have the same slope. Did you catch the if and only if? Where did we see that before? I hope you remember that's a biconditional from lesson 2.5. 2.5 or 2.4, I can't remember, but it's in there. Now, because vertical lines can't have a measure on their slope, we're just going to acknowledge that any two vertical lines have to be parallel. Okay, theorem 352, perpendicular lines theorem. In a coordinate plane, two non-vertical lines are perpendicular if and only if, there's the biconditional, the product of their slopes is -1. Do you remember what the word product means? It means the multiplication. You multiply the two slopes. And if you multiply the two slopes and you get that special number of -1, you have just shown by this theorem that the lines are perpendicular. Now again, vertical lines have no measure, so you can't multiply undefined by something. So we simply have to acknowledge that vertical and horizontal lines are always perpendicular. Because we can't measure, we can't take a slope of 0, which is the horizontal line, times an undefined value. It doesn't make sense. Okay, well if a line has a slope of a over b, then the slope of a perpendicular line will be negative b over a. The ratios a over b and negative a over b are called negative b over a are called opposite reciprocals. Caution: 4 given points do not always determine 2 lines. Graph the lines to make sure the points are not collinear. Example 3a, determining whether lines are parallel, perpendicular, or neither. Graph each pair of lines. Use their slopes to determine whether they are parallel, perpendicular, or neither. If you have access to graph paper, this would be an excellent time to take that out, pause the video, and then just go ahead and plot the points. We're going to press on, so let's go ahead and graph the points, and we get the following. Okay, now let's determine whether they're parallel, perpendicular, or neither. We use the slope formula, and we get the slope of uv, and we discover that it's equal to 3. We find the slope of xy, and we discover that it's negative 1/3. Now what's going to tell us if they're perpendicular is if we multiply the 2 and we get negative 1. They are negative 1. 3 times negative 1/3 is negative 1, so the lines are perpendicular. Let me add a word of caution. You can never say that lines are perpendicular just because they look perpendicular. Okay? We gave a graph here, and man, that's a good graph. It really looks like they're perpendicular, doesn't it? Unfortunately, you have to calculate the slopes and then multiply the 2 slopes. That's what justifies. So unless I give you the fact that they're perpendicular, or I give you the ordered pairs so that you can find the slope, unless I give you the information that they're perpendicular, you're going to have to do the calculation. Okay? I guess that's what I'm trying to say. Alrighty, determine each pair of lines. Use their slopes to determine whether they're parallel, perpendicular, or neither. So here are the 2. Now they don't look perpendicular, but again, we can't assume that they're not. So we do the slopes. Do the slope of line GH and we get 1. Do the slope of line IJ and I get negative 2. But when I multiply 1 and negative 2, I don't get negative 1. And this means that the lines are not perpendicular. They're not parallel either, because to be parallel, they'd have to have the exact same slope. So this is a neither. Graph each pair of lines. Use their slopes to determine whether they're parallel, perpendicular, or neither. Okay, they look parallel, don't they? Oh man, I want to say, well, obviously they're parallel. But again, I need to see that you know how to calculate slopes. So let's go ahead and calculate the slopes. All right, find the slope of line CD. Well, you're going to get 4 over 2, which is 2. Find the slope of EF. You're going to get 2 over 1, which is 2. And since the measures of both slopes are the same, we can say that the lines are indeed parallel. All right, try this on your own. Break out that graph paper. Go ahead and pause the video and then tell me what you got. Not that I would be able to respond. This is a video, of course. Ba-dum-bum-ch. Okay, let's see what you got. There's the graph. Hey, parallel, perpendicular. Do you remember what the situation is if they're parallel and perpendicular? Slope of Wx is undefined. Slope of Yz is 0. Yep, perpendicular. All right, go ahead and pause the video. Let's see what you get. All right, let's see what you got. There's the graph. Ooh, looks perpendicular. Slope of KL should be negative 7 over 2. Slope of MN is 1/4. Wait a minute, if I multiply the 2, no, the product is not negative 1. Hey, here's a classic example of something that looked perpendicular, but it was deceiving. Oh, you got to be careful, folks. You can't just say it's perpendicular or parallel from the graph. You have to do those calculations, okay? So I'm not doing this to be mean. I'm doing this because learning how to do slopes is an objective for Algebra 2, okay? But you got to go with more than just, well, hey, it looks that way, okay? All right, go ahead and pause the video, see what you get. All right, let's see what you got. There's the picture. Man, those look parallel. Hey, slope of BC is 2. Slope of DE is 10 over 5, which is 2. They're the same. So therefore, the lines indeed are parallel. All right, here's the lesson quiz. Go ahead and try and answer the following questions. Pause the video. Now. Yeah, now. Go ahead and pause. Hey, don't just sit there. Pause the video. Did you already pause the video? Are you done? Are you done now? Okay, all right. I'm going to assume you're done now. All right, let's see what you got. Use the slope formula to determine the slope of the line passing through the 2. You should have gotten m equals 1. For number 2, there's the graph. Whether they're perpendicular or not, 4 and 4 are parallel. 2 and negative 1/2 are perpendicular. And that is the end of the lesson. God bless you wherever you are today.